This time on KEI Fabrication. Alright folks, so let me explain. Alright, we're about to take our life in our hands. Hurry up, we're gonna go right down. Getting ready to go on another little reconnaissance mission. Nice. Hey folks, my name is Mike. This is KEI Fabrication and welcome to my shop. And this is my most recent project, and this is my shop truck, my daily driver, my race truck, my garbage truck, and my all-around performance vehicle. If you want to follow along with the channel, you can see the progress of the build on this truck and all the modifications that have been made. So this truck has already been to car shows, it's been road racing, it's been drag racing, and it's been circle track racing. We've got a bunch more new projects in the queue. We're looking forward to meeting more of you, and for those of you who've been with the channel for a while, thanks so much for watching. I appreciate your comments and the interaction and encouragement. Hopefully through this project we've gained some credibility with you folks, and let's see what's coming up next. I forgot to tell you, you might be wondering what the heck is this thing sitting over here. Well, before the snowstorm came, the day before, or actually the night before it started snowing, I cleaned up around the yard. I had an old junk John Deere lawn tractor, which I'll post a picture of me at the salvage yard. I unloaded the tractor and I turned around, I look behind me, and this thing is sitting right there on the area where you unload your scrap metal. And I made a deal with the scale house and they sold this to me. You'll see a separate video on that, and we'll do an attempt to get the motor running, and we'll go through what's good and bad about that. So sometime, hopefully not in the too distant future, you'll see a startup on this. We'll see what we can do to have some fun with that. Alright, so this is a go-kart I picked up, as you saw in the previous video, from the local scrap dealer. This was sitting on the pad just getting ready to be grabbed by the crusher and flattened, and I picked it up. It had all kinds of issues. The sprocket was all kind of wonky and put on wrong. See if I can find the ding in the teeth in the sprockets. You can see, hopefully you can see that. That's missing like half the tooth. It's kind of typical. A lot of times these things get low on air. The sprocket is so large it matches almost the diameter of the tire, and it bangs off the dirt and it knocks the teeth off. It needs to be that big of a sprocket because it's a heavy two-seater cart, not much power, so you need to give the motor the mechanical advantage. The other thing is the brake band was just about shot, and from the drive wheel flange to the sprocket it was spaced out with a bunch of these bolts, and then from the sprocket to the brake band it was spaced out with a bunch of these nuts. So I'm solving that. Should be a new clutch in the box. I've got a carburetor on order. This engine does run, but when I took the bowl off the carburetor, it had to have gotten some water in it, and it was rusty. But the motor itself ran great. Just wouldn't accelerate well, but no knocks, no smoke. So when that carburetor comes in, hopefully the engine will be salvageable. Hoo-wee! It's always a good day when the package from Ghost Power Sports shows up. Alright, let's see what came in today. So, alright, we got some logos, decals. Alright, so I'll unpack this box and show you what we got. Also what came in. Not too proud of that, but we don't make this stuff in the US anymore, so we gotta get it. So I ordered 4 new tires for this because these were pretty beat and they don't hold air. So I got these. It's the only place that I could buy a package deal to buy 4 of them for a reasonable price that all matched. So that's why I went this route. But everything else came from Go Power Sports. So the first thing out of the box is the seat. I was really surprised to find a direct replacement for the Manco. By the way, this is a Manco Rattler II. And it has the direct replacement nuts in the plywood, and it'll come up and bolt on like that, and then it has the 4 for the lower. So it has the little bolsters on it and the little rock guard to keep the dirt and stuff from flying up into the back. So that was really inexpensive. My plan was to, as a matter of fact, I had the plywood cut out that I was going to put my own cover on, have my wife do the reupholstery of make a new seat, because this had the wrong seat in it. But this was so inexpensive, I couldn't even buy the cushion material to do this. So I'm very happy about that. The next thing in the box is a new 80-tooth sprocket. So this should be identical to that one. And it is. Again, I want this cart to have some torque and not necessarily a high top speed, because it's just going to be myself and my granddaughter, or my son and my granddaughter, and then when my granddaughter gets old enough, she can give her little sister a ride. Brand new throttle cable because I want it to be safe. This one, it seemed to work okay, but it had a bunch of this going on, and I just don't want to take the chance of having it stick when I have either one of my granddaughters on board with me, or if it sticks on them. It does have a kill switch on the wheel, which is helpful, but I want to minimize the panic situations as much as possible. So what else we got? So I did the package of 10 wheel bearings. I'm going to replace them all because they all seemed a little lumpy. So that's something else we're going to do. Brand new chain, number 35 chain. Brand new 12-tooth 3/4 inch shaft clutch. So that'll go on. I think that's it. So yeah, not bad. I had almost entirely one-stop shopping for this. The only thing pending, like I say, is I had to buy the tires somewhere else, just because a set of 4 was really reasonable as opposed to buying a pair and another pair. I don't know, for some reason or another the price was just off. So hopefully I didn't make a mistake by buying that brand of tire and style. I think it'll be okay because this is going to be on grass and some pavement most of the time. So we've got just about everything we need. I took the tires off the rims and the back as you saw. I'm going to leave this tire off because I'm going to mock this up so I can put the new clutch on, and I'm going to make some aluminum spacers that actually register on the drive wheel hub here, register in the center of the sprocket, and then go through the sprocket, and another spacer that will register the brake drum and space it off of the sprocket in this direction. So you can see they must have had a catastrophic chain failure and tire blowout or something, because that's the chain wrapping around the rim. So the tire must have popped off the bead, probably knocked the chain off the sprocket, and then wrapped the chain around the thing. It must have made a pretty good mess. So anyway, trying to make this reliable. I have very, very, very little money into this cart, and when it's all said and done, I could probably at least double my investment. In terms of return on my investment, I think I can double it. So that's kind of how I try to operate. So anyway, I'm gonna, now that the wheel bearings are in, I was waiting to put the tires on those rims. First of all, I need this one to not have the tire so I can measure and see better in here and not be obstructed by the bulge of the tire and everything. So that's why that one's not on. And I was waiting for the wheel bearings to come in, and other than that, I should be pretty much ready to rock and roll and start putting this together. So I'll keep you updated. Alright, so I got some diagrams here to make my spacers up. This is the flange on the drive wheel that's here. I need a 0.9125 or 913 thick spacer to go from that little drive flange to the sprocket. And then I need another one that is going to span from the sprocket to the brake band, but the only way I could take the measurement is from that drive wheel flange to the sprocket. I'll subtract that out, and I need to make a second spacer that's going to go from the opposite side of the sprocket and reach out to the brake band. And I want to make sure that I have a register that will pick up the sprocket inside diameter, so that'll run through and you're not making or relying on the bolts to center the sprocket, keep it from having a bunch of run out, and then that'll protrude through, and then the adapter for the brake band will slip over that, provide the right spacing, and that'll also have a register on it as it comes way out this way. So I'm going to incorporate the bolt circle in my spacers. I'm going to 3D print these, mock the thing all up to make sure it's okay, and then I'll go ahead and machine them out of aluminum. So that's probably going to be the most difficult thing. I'm trying to make it so it ends up being reliable and just doesn't burn up chains, or the sprocket and the chain have issues where the chain keeps jumping off. And I'm trying to take as much pressure off of these long bolts that are going to go from here all the way through to the brake band, like what was utilized before, except between the sprocket, as I said, between the sprocket and the brake hub, there were several nuts stacked up, and between the sprocket and this drive wheel there was several nuts stacked up. And in a pinch I probably would have done the same thing just to get it on the road and get going, but I want to do it right while I have the opportunity and not be chasing these run out issues and reliability problems in the future. So I'm going to jump on the CAD software and make a couple of these spacers, and again, like I said, 3D print them and see how we make out.
Well, I failed on that one. The pilot I was hoping to use to locate the sprocket also needs to clear the 1-inch axle tube, and if I clear it, the sprocket will not have a register on it. So the one solution, I can do the exact same design. One solution is to open up the ID of the sprocket, kind of to match the ID of the brake drum, and then it'll be the same size register all the way through. So I just got to rethink it. I was trying to make it right, but didn't anticipate some of these issues. So we're going to go back to the drawing board, literally. As a result of that, you can see that by the time I clear this pilot of the axle, that's about the same amount of room that I have to line up with the clutch. So still got some work to do.
Alright folks, so you may have seen the dilemma that I was faced. This is the adapter that I want to use to space the sprocket out properly to line up with the clutch on the engine. It's just a 3D printed prototype to prove out the concept. I think you saw that the diameter of the inside of these bores had to be increased because they were hitting on the 1x1 axle tube. In order to make that work and actually have a pilot for the sprocket to register on, I had to increase the inside diameter, which means the diameter of everything else in terms of my pilots had to increase as well. What that means is the inside diameter of the sprocket has to be increased. Well, I don't have a good means to put a larger hole in something that has a hole that already exists. So what I did was I 3D printed a fixture that once it's bolted to the sprocket, it'll actually center the drill to use either a hole saw or some other means to even center it up in the bridge port, so I can use a cutting tool to increase the size without going out and buying some really expensive giant drill bit. So my choice really is only to use a hole saw. And I really want this to be perfectly concentric with the sprocket, because the whole point of going through this exercise, if you remember, is to eliminate the stack of nuts that was used to space this off, and then the 4 bolts that held the sprocket on were the only things that were holding it in the center. So I'm trying to eliminate any run out on the sprocket and the brake drum. So this is only going to be utilized to transfer this pattern to a solid chunk of aluminum, and then I will use the solid chunk of aluminum as basically a drill guide to allow me to remove the material from the middle of the sprocket. So I'll let you know how that all works out. Alright, so this is the material that I purchased to make the spacers out of for the sprocket hubs, and I only need like about 2 inches worth of this material, but this is the correct diameter if I ever need to make new pieces for fixturing for my rear end narrowing equipment. These are what I make the inserts for the axle bearings and for the carrier bearings that the alignment bar goes through, so this comes in handy. So the first thing I'm going to do is knock a piece of this off to make my drill fixture from, and I'm going to transfer, using transfer punches, this to the center. I'll use it while it's in the lathe and facing the surfaces off. I'll use a center drill to locate the exact center of this, and then I'll drill through, and then I will be able to transfer, use that as an alignment to position this, and then use a transfer punch for the other holes that need to bolt into the sprocket. This will be clamped into the vise on the bridge port, so I can bolt the sprocket to it and basically, again, use it as a fixture. So when I drill, I'm not trying to drill through a much larger hole that I can't use to center whatever I use to open that hole up. So here we go. Alright folks, so all I really did was clean the face off. I had a center drill in the chuck and used that as a pilot, and then I took a brand new number 7 drill, drilled all the way through, and put a chamfer on this. I'll flip it around, turn down the outside of this, and face off the other side, so hopefully the 2 sides are parallel. And then I will finish drilling the size that I'm going to use for my transfer punch, which is on my 3D printed fixture, which is a 1/4 inch. So I'm going to finish this up. I didn't film any of the machining because it's pretty boring. So when I get it done, I'll show you what I'm going to do with the fixture that I 3D printed to make this accurately bolt to the sprocket and keep it centered about the hole of concern here. Alright folks, hopefully you can see what I was after here. This is a 1/4 inch transfer punch and it was a nice, very small interference fit into the aluminum fixture, and then this is nothing more than a drill hole guide that I'm going to use transfer punch. I've got a light clamping pressure just to hold it so I'm not chasing it around, and this has enough thickness so it's kind of holding my transfer punch good, and I'll transfer these things. Now if I had a rotary table for the Bridgeport, that would have saved hours and hours of work. I just don't have one. Every time I find one, I either don't have the cash to afford it, or it's just plain old the wrong one for my application. It's either giant or, you know, it's in poor condition. So I only need 4 of these holes to match up with a sprocket, but I'm going to transfer all of them just because you never know. I'm not going to drill all of them and tap them. I'm actually going to tap these. And so hopefully what that'll do is when I go over to the Bridgeport and I line this up and drill the holes and then tap them, the sprocket, when it's bolted on, will be concentric with this. This will get mounted in the milling vise, and then I can do whatever I need to do to open that hole up on the inside of the sprocket. So this 3D printed piece was nothing more than get as far as I've gotten right now, transfer that information over to the piece that actually is going to become the fixture. So there's the transfer. It's the best thing I could think of with the resources that I have, just to try to solve the problem of not manufacturing run out into this system. My whole point of going through this whole pain and suffering is to eliminate the run out and strengthen the connection system to the drive hub and just eliminate frustration down the road. So we'll go through some frustration now. Hopefully that'll be rewarded in the end result. Alright, so what I did was I milled off the edges of this, so when I flip it over it'll sit in the milling vise and it'll be parallel. Once I get that done, I'm going to put a pilot 1/4-inch diameter, and I'm actually going to use the table of the Bridgeport so I can plunge into that centering hole, and that's the only way that I don't have a bunch of dial indicators and everything to figure out where the center is, so I'm just going to zero in on it by putting a guide pin in here and finding that hole. Alright, so I just drilled the last hole, and I'm going to pull this out of the vise, tap those holes, and I'll put it back in the vise for the final time, locate the center, bolt the sprocket to it, and then we'll work on opening up the bore of that sprocket. Long way to go. I'm still nowhere near where I need to be. Some of you may have been asking, how come you just didn't open the center up on the lathe? Well, my lathe doesn't have enough swing, which I'm trying to demonstrate here, and even if I did want to open that up on the lathe, I'd still need some fixture to put in the chuck. But believe it or not, it misses it by on the radius, maybe by a 1/2 inch. So that's why I'm going through all this pain and suffering. Alright, hopefully if you've been in with me this long, you can see the whole point of that fixture. Get down here so you can see it. The fixture is clamped in the vise, and then the sprocket's bolted to the fixture, and that centering hole with a guide pin in the chuck is helping me locate it. So everything's locked up. I got the ways of the Bridgeport locked in. So now I have to figure out what am I going to use to open the center of this up. Alright, so this is probably way too excessive for what I'm trying to do here. You know, a go-kart sprocket, right? So the only thing I could think of is make the fixture, bolt the sprocket to it, use the fixture to center it in the center of the boring head. A while back I had a project that required to change the ID of rims to fit on the Mazda, and my son recommended to get one of these boring heads, and because I changed over the 5-lug spindles, it was no longer necessary to modify the ID of the rims. So I've had this for a couple of years and I've never used it. I just took it, it's brand new out of the box, and some of you may be screaming, no, that's not what it's used for, you're doing it wrong. But anyway, I had to open up the diameter, the inside diameter of this, and I'm using this to traverse the boring bar to make the cut. And I've made 2 cuts so far, and making a final cut now, and I'm just using the dial indicator so when I move this in to match the numbers here that I needed to go, as far as the radius is concerned, I need to go 135 thousandths. So I'm almost there. I'm going little bites at a time just so I don't ruin the cutting head. Trying to understand how to use a boring bar. This is the first time I've ever even taken it out of the box and looked at it. And all the other attachments. Hopefully, when I'm all done, it'll be concentric with the teeth and all of the spacers that I am going to manufacture work with that inside diameter and the pilots to register it so everything's concentric. Alright, so the whole purpose of this whole exercise, what you do for your grandkids, right, was, as I had indicated, the sprocket was spaced off of the drive wheel with nuts going between them, and I wasn't happy with that. The other dilemma is that the sprocket wouldn't even fit over the drive flange because it was too small. So I 3D printed some prototypes to get this so it mates with the drive flange, and then the sprocket goes on, so this would act as a really good spacer for the sprocket. Then another spacer goes on, and then the pilot on the inside diameter of this and the outside diameter of the first spacer registers with this, and then the brake drum goes on this. Now, just to get to this point, I had to go through everything I just did just to get to this point to ensure that the thickness of these spacers are correct, so when the drive wheel is bolted on, it lines up properly with the clutch sprocket. So now that I've got this all together, I've got the long bolts down at the other shop, put the brake drum on, bolt it all together, just snug it up, slide it on the go-kart, and then I can take my final measurements of the thickness of the spacer requirements, because, you know, the center of the engine, you know, is a good 15 inches above the sprocket, and you're doing the best you can to measure and make sure everything is lined up with straight edges and such. I couldn't do that accurately because I couldn't even bolt the sprocket on because it wouldn't fit on the drive wheel as it is. So that's what I'm going to do now. I'll go down the shop, bolt this all together, slide it on the go-kart, tighten the wheel up where it belongs, and then double check my alignment with the clutch. Alright folks, I got it bolted up to the drive flange. There's the black 3D printed spacer, the sprockets on the brake drum spacer, the brake drum, and let me show you how it looks on the machine. Alright, the first priority is concentricity, right? Well, if you look at the sprocket, anyway, you'll have to trust me that there is the concentricity issue of my fixturing and all of that. I'm very relieved, so that works great. However, and the whole purpose of doing the mock-up here was to check a couple of things. First of all, you can see that maybe you can't, but I have to add like 1/8 of an inch to this spacer.
relationship to the clutch. That'll push that out, and it'll actually push the brake band out the proper amount as well. So I wanted to do that. The other thing I discovered in this process, and I would have never been able to do this unless I went through this exercise, is the drive flange on the wheel is actually causing the sprocket to run out this way. So the concentricity is good, but there's some run out. So what I'll do is I'll take the wheel up to the shop and I'll knock it around to get the attachment flange running parallel to the wheel and perpendicular to the axle centerline, and then that'll go away. So I am actually going to consider this a complete mock-up prototype, and I'm going to start turning these on the lathe and getting those good to go. So I think I'm into this for almost 5 hours just to get this far, and I haven't even cut any chips on aluminum yet. Alright, I took the time to get this thing fired up just temporarily. I'm going to run a couple of cuts on this thing, and actually by just wire nutting the wires together where the switch normally goes, it'll actually save me a trip to the store until I have an opportunity to go. It's just a better time to go. So we'll see how this goes. I got to slice off 2 chunks. Once I square the end off, I'm just doing that now just to get it out of the way and as a test cut. So we'll see how it goes. Alright folks, there's at least 2 hours of machining into this thing. It's going to eventually look like this. I just got to pull it off and put the 4-hole bolt pattern in. Got a whole pile of aluminum shavings. The cutoff saw worked really good. It was just super slow. I understand it's 3.5-inch diameter bar stock, and it's probably the wrong blade. It's whatever came with it. But I squared the vise up with the blade, and I tightened the pulley up on the motor, and it ran fine. It probably was cutting for almost an hour, but I made 3 slices, one to square the end off, and then the 2 chunks I need. So the next step is to turn this piece into this. So I'm going to be back on the machine for probably another 2 hours, because it does take a substantial amount of time to bore through the center and turn the outside down so we have the register like this one. The good news is the protrusion here is not as far out as this one is, so it shouldn't take as long. But by the time I machine to clean the outside, square the surfaces up, and get to the point where I can put the ID recess in it and then start turning the OD, it still takes a bunch of time. So I'm going to start doing that. I'll let you know how I make out. Alright, there's number 2. Supposed to look like that. So now I just have to knock the holes in it. Should be done. So let's see, what time is it? So that was 2.5 hours right there. Alright, well, there they are. I got my 3D prototypes, and then I've got the actual ones. Now we get to put it all together and see how it works. Alright folks, here's the stack up. There's the drive flange, sprocket spacer, brake drum spacer. I worked quite a while getting the run out reduced to a minimum as far as the potato chipping of the sprocket, and it's pretty good. So this is way better than it was from the factory. The brake drum's running pretty true, so that should make this is probably the poorest braking system you could have on a go-kart, and the fact that it's running true, I'll get the maximum amount of performance out of a not so good brake system. So I'm going to take this down to the shop and put it on the cart, make sure the sprocket lines up. I may have to adjust the thickness of these spacers just to get it perfectly aligned, but we'll cross that bridge when we come to it. Alright folks, I'm pretty happy. Brake band's lined up and the sprocket is lined up perfectly. So put the tire on, put the chain on. I'm gonna have to give her a rip. Alright folks, so what I'm doing here is I'm using my hydraulic shop press as my bead breaker for these go-kart tires and rims. So what I got going on here is I put a metal rod in my bench vise to hold the rim from moving around, and then I picked up some tire spoons at a yard sale, and these things with that special hook and the curvature at the end really pay off when it comes to removing these. You can see I've got the first bead off. I'm working on lifting the second bead off. So if you ever see these at a yard sale, I highly recommend picking them up. Spiffed up the rims, getting ready to knock the bearings in. Took all the rust off the beads, and we are going to mount the tires up here in just a moment. So when you folks are putting the bearings in these go-kart wheels, do not forget these spacers that go in between the inner bearing and the outer bearing. They are designed to hold the race in position. So if you don't put that in, if you over tighten the bearing with the nut, or even if you only tighten it up to the correct amount without that spacer, as the go-kart goes around corners and such, it'll try to rip the center of the bearing out. Just because I know everyone's going to have one of these laying around, but by the way, a crank pin for a L model Gravely tractor is the perfect diameter to use as a bearing driver. So one of the things you want to make sure you do when you mount these tires on the rims is you got to kind of take the perspective of, because these tires are directional, the ones that you have may not be, but you want to make sure that, you know, if you're looking at the rim and the tire rotates clockwise, you know, this is the outside of the rim. This is going to be the left front, so my tread is oriented this way. When I mount this rim up, I'll make sure that the tread is oriented the opposite way with the valve stem facing up. Just trying to save you the trouble when you get all said and done and it's all mounted. You don't get to the chassis and put the wheels on and realize that your tires are going the wrong way. So I got the front wheels on. I got the treads pointing in the correct direction. The one thing I need to fix though is, even with the same spacing between the spindle and the tire, you can see that this tie rod end is almost touching, and with the same spacing on this side, I've got 5/8 of an inch between the tire and the tie rod end. So what that means is it has different toe out on turns from left to right. So before I lock this down, I'm probably going to have to take that spindle off and tweak the steering arm a little bit just to get the toe out on turns correct. Probably work real good for turning left all the time, but that's not going to always be the case on this one. Alright, so this carburetor must have been full of water because the engine on the go-kart didn't run. It ran, but it wouldn't accelerate and it would only idle, so the high-speed circuit was plugged. I took the bowl off and it just loaded with rust, so rather than even bother with this, I decided to try and order a carburetor. So this carburetor was less than $9 shipped, and just taking it out of the box for the first time, just see if it's similar. So it did come with a new manifold, and on first glance it looks like it came with everything that the old one did. It has the crankcase ventilation tube and the supply tube and the same style throttle lever, and there is no choke on these. It uses the primer bulb, so it does look identical. So this will be a fun experiment. I'm gonna flush the tank. I've got my catch can here. I'm gonna flush the tank because I suspect that at some point it filled up with water, so I'll have the gas come out of this little tube here into this container, and then once I'm comfortable with that the gas line itself isn't collapsed or attacked by the ethanol fuel and there's no water in the tank, then I'll hook the new carburetor up and we'll give her a rip, see how it runs, or if it runs. So you can see I got full flow out of the tank, and the gas is coming out pretty clear. So I think it's safe to put the carb on, see what it does. Alright, carburetor's on, got fuel in the tank. I'm gonna do the old primer. Really can't feel any fuel circulating through it yet. I don't know if we're putting any fuel through it or not, so I haven't tried to start it, so this is the first time we'll give it a rip, and I'm not sure if the toggle switch on the ignition up on the steering wheel is working. I'm pretty sure I got this one in the correct location here, so let's see if it fires. Smell fuel. Just change the toggle switch on the steering wheel, see what happens. Thought I heard a little bit of a it didn't run too bad. We'll have to see. You know, you saw no smoke. It's not making any ticks. It accelerates good. It's still a little cold, so maybe I gotta wait for it to warm up because this is not a carburetor with a choke on it. So I'll put some heat in it, see if it runs and idles any better. But so far, it's running better than it did. Alright, so can you hear it searching? Well, let me show you why the $9 carburetor is $9. In a moment here, I only got one hand left to do anything. But I am spraying some ether in the throttle shaft of the carburetor. Watch what happens. So it floods it out initially and then idles way up. Let me see if I can show you how bad the throttle shaft play is here. It took me a while to observe it with my own eyes. It's really tough to get an idea for just how much displacement is going on there. Alright, because I am stubborn and I don't give up easily, I'm trying to solve the issue of the massive vacuum leak that is going on as a result of the throttle shaft. So what I did was used a center drill that has a reasonable taper, and I just gave it a quick touch to put that cone shape in here, and then the throttle shaft, once it's in position, that O-ring should sit nice there, and there's a spring, a throttle spring with a washer that'll sit on top of that, and I'm hoping between the throttle spring and the washer and then the throttle plate or the blade installed, it'll put a little bit of pressure on this O-ring and seal it up. So I'm going to give it one last try, and if it works, we all learned something. If not, we'll try a different approach. So there's it all assembled. The
choke and throttle, the throttle plate and shaft seem to be fairly free. I'm hoping that the O-ring will provide the sealing to prevent that vacuum leak. So when I get back down to the other shop, I will try to see how it runs. I'll let you know. Alright, so it is running significantly better. It's not perfect, it's still surging or searching a little bit at an idle, but it's tolerable. I think the O-ring definitely helped out because it runs better than it ever did. I did have to adjust the float level up a little bit just because when you held it down full throttle for, let's say, a 10 count and let off, it would stall. So I suspect it was pulling the bowl dry. I raised the float, and it's might not be perfect, but it's better, and it should save it from stalling and then having to get off the cart and start it back up again. I know there's no load on it, so that situation might be exaggerated just because the engine's free revving high. So I think that's a go. I'm going to replace the throttle cable. I'm working on the wheel bearings and tires up at the shop, so we're going to continue messing around with it. Brand new throttle cable because I want it to be safe. This one, it seemed to work okay, but it had a bunch of this going on, and I just don't want to take the chance of having it stick when I have either one of my granddaughters on board with me. Or
next time on KEI Fabrication.
Well, folks, we're trying to get this toy hauler conversion move further along, and we've had torrential rain last night and today, and we're just trying to make the best of it and get further progress done. We got the metal structure that the door is going to be attached to, the metal framework, and we are ready to stand that up in place. So we're going to do that in the next few minutes. Hopefully that'll go well.